How about, can you hear me now?
Yay, there we
Okay.
go.
Sorry about that, everyone.
Hello, Mr. Oranaka. How are you?
I'm doing well. How about yourself?
Doing well.
Good, good.
Better now.
Looks like we have a good group here.
We certainly do, and some repeat names that are going to have some questions. I'm
All
very
right,
excited. Yeah.
right.
So
That's
let's
awesome.
let's roll with it. Mr. Oranaka, can you tell us a little bit about engineering and robotics?
Okay, yes, I can. Engineering and robotics consists of a lot of areas that contain engineering, like mechanical engineering, electrical engineering. Um, we don't get into anything like sound engineering because we already have some programs that that hit those subjects. So, but what I try to do is give everyone a flavor of the different engineering areas out there, and the robotics fits all of those. I mean, in robotics, you get electrical engineering, in robotics, you get structural engineering or mechanical engineering. We do a lot of things with design because I want to make sure that we have a solid foundation in how to make things. The way I approach it is we use something called the design process where you come up with an idea. So you take an idea from in your head, okay, you create what I call a vision, because you have to understand what you want before you can actually do it. And once you create that vision, what you want it to look like, what you want it to feel like, and all of those parameters, then we start in the process. It's a six-step process. And what we do is we go through the steps in order to create your idea or to make it so that you can hold that idea in your hands. I have a 3D printer. We use 3D solid modeling where we can create parts and then send them to the 3D printer, and we can actually print them. And I do things like that all the time. Just a thing that I do because our 3D printer prints in plastic parts. So what I've been able to do is when I break something at home that's plastic, I just model it in my 3D modeling system, and then I send it to my 3D printer and I print it. Okay, this is something that I've made. This is a foot pedal for a kitchen appliance that is very expensive. They cost about $40 each, and unfortunately, they tend to break. So what I did is the last time I broke one, and this was actually years ago, I actually modeled it in my 3D printer system or my 3D modeling system and then printed it. Okay. The problem with it is it's way too big for my 3D printer. So I had to figure out how to make it. And I actually make it in two different halves. And then I put it together to look like this. And it works real well. And again, whenever I have plastic parts, that's how I fix things. I don't buy them anymore. I just make them.
That's such a cool, like, don't worry, I'll make it. That's such a nice response to when something breaks, like, oh, no biggie, I can just make one.
Yeah. Well, it really tests your knowledge and your skills and especially your creativity.
Hmm.
If you're a creative person, then engineering and the things I do in my class are perfect for you, because in order to be an engineer, you have to be creative. In order to be good in design, you need to be creative.
I think that's a big misconception about engineering is that it's all math and 90-degree angles and structure, but the creative problem solving that engineering inherently does is so wildly creative. Like just figuring out different avenues to make things work. You said it. You have to have some creativity there, right?
Right, right. And it's all a matter of, well, something I call perspective, how you view things, how you see things.
Hmm.
And that's what we try to work on is instead of always looking at things from one direction or from one viewpoint, we try to look at it from three different, or actually not three, all different viewpoints. One of the examples that I use is I'll draw a circle on the board, and I'm giving away a secret now, but I'll draw a circle on the board and I'll say, what does this mean? And actually, what I'll do is I'll write problem and then I'll circle it. And I'll ask my students, what does that mean? And they come up with all kinds of answers, all kinds of creative ideas. But what I'm trying to symbolize is that when you have a problem, you can approach it from 360 different angles. Okay. And that's where you can really be productive, is because if one viewpoint doesn't work or one perspective doesn't work, you try to choose another perspective, and you keep on changing perspectives until you until you solve your problem.
Mhm. So day one, when you do that, you will absolutely know who listened to your talk this evening and who missed out.
That's right. That's going to be the first question I ask.
I love it. So you have a question already. What 3D model software do you use?
Okay. I use something called Autodesk Inventor, which is pretty high-powered, heavy-duty piece of software. I have been getting into something called Tinkercad, which is from the same company, but it's a little more simplistic. It's not quite as powerful, but some people find it they easier to use. I prefer Autodesk Inventor because you can do all kinds of things with it. I mean, it's just I mean, again, if you're creative and you can look at things with different viewpoints, you can find lots of ways to problem solve with Autodesk Inventor.
Um, I I mean, like it's your class fascinates me because I know nothing about it, so I'm always like, tell me more about all of these things. Um, you had mentioned that some of our classes, you mentioned sound engineering specifically, and that would fall under Mr. Hunt's class, like um, uh, video production and recording arts. They
Correct.
touch
Yes.
on that.
Hmm.
We did have a question before when I was talking about the electronics and computer tech class, Mr. Isula's class, about how different or how similar your classes are. And unfortunately, Mr. Isula couldn't join us, and I couldn't really answer that question, but I was hoping you could answer it.
What's the question?
Sorry, I'm very wordy. The question is what is the biggest difference between your engineering class and Mr. Isula's electronics and computer class?
Okay. Mr. Iasula would be more of an electrical engineering or an electrical technician type of class. Um, they look at electronics and how they're used, how they're put together. They fix computers, they can fix TVs, just about anything electronic. Where my class, I tend to look at different aspects of engineering or the different types of engineering. What I like to do is, first I try to get a survey of my class and figure out what types of engineering they are interested in. And then I kind of mold my class to follow what the students are interested in as opposed to, just a generic curriculum.
Mhm.
We'll find out what my students are interested in, and then I will create the class to pursue those interests.
I love that. So speaking of, in your class, what does a project look like? Is it like a group or is it an individual project? And are there any projects that stick out as like a favorite of the students?
Okay. Well, the way I approach my class is the first thing we do is we work on something called activities. And the activities are skill builders. So there's certain skills that you need to build, you need to work on, you need to perfect. And then once we get through those skill builders, then we go to a project. Okay, and what a project is, it's a close-ended project where we kind of know what the end result is going to be, but they utilize the skills that you built during the previous activities. Once we get done with the project, then I do something called an open-ended design problem, where you use where it's a project where you use the skills that you should have learned previously from the project and the activities, but you also get to use your creativity in order to complete the design project. Okay. Um, and that's trying to get you to think outside the box, so to speak. Because a lot of students ask me, Mr. O, what's the answer supposed to be? And I'll look at them and I'll say, whatever you want it to be. And that is the absolute truth. If you can, again, if you can create a vision of what it should look like, the solution should look like, that's what you create. And there are times when people don't end up with, or students don't end up with a final project, but that's not such a bad thing, because some things are just take too long to do, or you run into obstacles that you can't solve. But what's important is that you've created the vision and that you can relay that vision to people. Okay. One of the things, one of the examples that I use is that um, engineering is actually a communications uh, type of process. And what I always tell my students is if you can't communicate your ideas, and it's $1 million idea, someone's going to come up with that idea first and beat you to the punch.
Mhm. Oh, well, yeah, and you always want to be the first one there, right?
Yep, absolutely.
Do you guys talk about patents at all?
I'm sorry?
Patents? Like,
Patents. We
yeah,
do, we do, we do talk about patents, but it's very difficult to get a patent
yep,
these days. Okay, and what I've learned about patents myself is that many times they aren't worth the money that you're going to spend on them because all someone really has to do is differentiate your idea a little bit, and they can get by your patent. But what I do tell people, and this is true, is that if you are the first one to market, you are usually the one to gain market share because you're ahead of everybody else.
mhm,
So although patents at times are important, they're not really a necessity these days.
got it, got it. You have another question. Uh, Caden writes, I am very interested in renewable energy and environmental engineering. Is this within your class structure?
Yes, yes, absolutely it is. We have added that to our program. I work with a company called Project Lead the Way. Some of you might have heard that before. And there is a course that I have added to my program called Engineering Essentials. And that talks exactly about that, about recycling, about renewable energy, about all those environmental engineering. It talks about all those areas.
Awesome. Yeah, and I mean, from what you said before, it sounds like even if it was not embedded already, it'd be something you would let students kind of pursue as a form of engineering in your class.
Sure.
Yeah.
Yep. Yep.
So let's talk a little bit about like college and where your course can take you if it's, if it's right into the workforce or what kind of programs and articulations you guys have with
Okay.
schools.
I do have articulation agreements with Erie Community College and Niagara Community College, and then also RIT. But what I found is that the Project Lead the Way courses that I teach are taught nationally.
Mhm.
And there are a lot of schools that will give you credit for the courses that I teach. To the juniors, I actually teach 3 separate courses, but I put them together in such a way that you really can't see the difference between the 3 courses. But when you do go to college, you can get credit for those 3 separate courses. Same thing with the senior year. I teach 3 different courses, but again, I mold them together so it looks like one. But again, there's another opportunity for 3 separate courses when you get to college.
Mhm. So, is there a large job market? I mean, everything is kind of engineered, right?
Everything is engineered. Everything that you see and you touch, and I mean, the chair you're sitting on was engineered. And I
Oh,
would
it's not
hazard to
very
guess,
comfortable.
I would hazard to guess that everybody that's here is sitting on a different chair. So look at how many opportunities there are for engineering.
Oh, absolutely.
Yeah, and something simple like that.
Hmm.
The other thing that I really find fascinating is as I've been teaching this course, I've been doing it for 15 years. I've had the opportunity to go to RIT in Rochester to take courses and to help and also teach courses. And I've met some really interesting people at RIT. And I've met people who have taken engineering and have not really gone to work for a company or to go to work for someone. What they've been able to do is follow their passion for something that they like to do and then turn that into a career. For example, I met a gentleman who was going to school for mechanical engineering, and he played baseball because he really wanted to be a professional baseball player. Um, and around his junior year, maybe beginning of the senior year, he realized that he wasn't good enough to be a professional ball player. But so he kind of set that passion aside. But when he graduated, he answered an ad in the paper for a company called Easton. Okay. And it was Easton Sporting Goods. And lo and behold, they were looking for someone to design baseball bats. He was able to get the job. So, what his job consisted of designing baseball bats, and then making the baseball bats, and then he would spend a day or two in a batting cage hitting baseballs to see how they worked and how they performed, and then what modifications he might want to make in order to make them perform better.
It all worked out.
Yeah, and then I met a woman who was an avid bike rider. She loved riding bikes, and uh, she, at one point in time, uh, she started to have back problems. You know, she would ride her bike and she would get off the bike, and her back really hurt, and she was afraid that she was going to have to give up bike riding. Um, until she started doing some research and found out that bikes were not designed for women, they were designed for men. And that seemed to be the stem of her problem. So what she ended up doing was designing a bike for herself, and it worked out really well. And as people heard about it, they started asking her to make bikes for them. And she turned that into a company. So now she makes bikes for people.
Just like that.
Yep. Yep.
So you have another question, Mr. O. Do we touch base with coding?
With coding. Yes, we do. When we get into the robotics sections, we code using a program called Robot C. And Robot C is very similar to C++ or Java. There's a number of programs out there that are pretty similar. And I've, talking to people, talking to students who have gone on to coding, it's not a difficult transition from Robot C to some of the other programs that are out there.
So, I think you might have touched on this already, but junior year versus senior year, do they look similar? Do they look super different?
Junior year consists mostly of individual work, although I do group work there. But what we're trying to do the junior year is to build skills. Okay. We're trying to build individual skills, although we will do some group projects in the junior year. In order, because you always need to work in groups. When you get into your career field, you will usually become part of an engineering team as opposed to working on your own. Senior year, we do a lot of group projects because I want my students to become more familiar with doing that. And the neat thing about that is the senior year, we will one of the units that we'll do is we'll actually design robotic games that you will come up with the ideas, you will develop the game, you will develop all the rules. I mean, every aspect of the game. Then you will document it, and then what I'll do is I will pass those games off to my juniors. You'll get a chance to play them, of course, but I'll pass those off to my juniors to see how well you did in your documentation and how well you can communicate your ideas.
And do they get to design the machines and the robots that participate in the games as well, right?
Well, they get to design it, but again, the juniors can design their own. We're not concerned about the
Oh,
machines and their design.
got
What we're
it.
concerned about is the game, the rules of the game, how it's played, and then every student designs their own robot. Again, you have a vision of how the game should be played, and then what you should design and build in order to be most effective in that game.
Gotcha. You have another question, Mr. O. Do you do first? First is in all capitals, like FIRST.
First robotics. We used to do it. We don't do it anymore, unfortunately. But we used to do it. It's a great program. I wish we still did, but it just turned out to be too much of a hassle. Took a lot of time and a lot of effort, and I found that we could use that time and effort better in other areas.
Got it. So do you expect students to have any prior knowledge of engineering before they enter your class?
No, I don't expect that. But what I do expect my students to do is to be motivated, okay, have a good work ethic, um, and be willing to ask a lot of questions. Okay, questions are what makes the world go round. What I try to do is to prepare my students for college and career, and I try to focus on things called or what I call transferable skills. And those are skills that you can use any place and anywhere. For example, for students who come through my program and they decide that engineering is not for them, that's okay, because the career you choose will probably use a lot of the skills that I'm going to teach, or that you're going to use in class. Things like doing research. Research is not an easy thing to do, especially on the internet. And I will show you at least methods that I use that seem to work. And I've been honing my research methods for a long time. And anything that I can do to get you there faster is certainly worth the time and the effort.
Um, One other question that had come up in a different talk was trends in your industry, and if that's something you're able to keep up with in the classroom.
Unfortunately, a lot of the trends are moving a lot faster than we can
Yeah.
do in the classroom. Okay.
Mhm.
But again, the skills that I teach will help you learn those trends quicker, because you'll have the skills in order to be able to, do the research and practice and things like that.
Absolutely. Um, so just a little reminder, if you have any questions, because we're kind of winding down, we have about 8 minutes left with Mr. Ornaka. So if you have questions, feel free to type them in the chat, or just unmute and go ahead and ask your question. But other than that, I mean, can you tell us about some of your successful alumni and what they're doing now?
Yes. One student that I like to talk about in particular, he came through my program about 6 years ago. Came in as a junior. He wasn't born here in the U.S. He was born in Russia and came over here when he was 9. Um, and he came into the program junior year, and he really didn't know much. He struggled to learn some things, and by the end of the junior year, he was doing fairly well because he worked hard at trying to learn the skills that I teach in my class. Around the middle of his senior year, he got a job at an engineering company, and his job was actually fixing uh, parts that engineers had designed that didn't work, or mechanisms that other engineers had designed and didn't work. And here he is, a high school student, who they'd give him these things that sometimes he didn't even know what they were or what they did, but he would figure it out. And I still am in contact with him, and he tells me, he says, the one thing I remember that you told me is that when you don't know what to do, you have to do something, or you have to start someplace. So he would just start doodling and meandering and things like that, and thinking about what was going on. And eventually it would hit him that this was the problem and this is what would need to be done. And he would end up fixing it. And again, like I said, he was he hadn't even graduated high school yet. Well, he went on to ECC and got a degree at ECC, and then went on to UB and got his mechanical engineering degree. And currently, he is working for an electrical company designing high voltage circuit breakers. And then on the side, he has his own design company where he has clients that come and say, this is what we need, make something for me. And he does that on his own also. And he's actually building that company. He's starting to hire people to help him out. And it's all because he is motivated, and because he wants to do things and get things done.
Right. Absolutely. I mean, it's taken him really far. He started in high school. That's the coolest part.
Right, right. And he did designing all through his college career. He just kept moving to better ones and better ones and better ones.
Yeah. You have another question. Is your program recognized by UB or Buffalo State engineering departments? We kind of talked about this.
Okay, not I'd have to say no. I mean, I'm in contact with UB, and I do have some contacts there. But if you decide to go to UB, you can get some credit for my courses. Buff State is not Buff State is not really an engineering school. It's more of a technician school. But if you decide to go there, I have students to go there, and they're successful in those programs also. Matter of fact, one of my 4-year degrees is from Buff State as an industrial engineering technician.
Mhm. So I guess the UB piece is kind of not formally, but you can get credit for the courses.
Right.
Yeah. Anybody else have any other questions while we wind down? I want to make sure everyone's questions get answered. But otherwise, I have one. Oh, you know what we didn't talk about? Do you get to do any field trips in like an ideal normal
Well,
year?
yes. One of the field trips we do in a normal year, we go to GM and we see what GM does on their assembly lines and the engineering
Oh,
departments and things like that.
mm-hmm.
We go to another place called K Technologies in Hamburg, and they are top of the line electronics engineering. Some years we go to Moog, and I think that's about it. We do Tech Wars at NCCC. So yeah, we do try to get around and do different things outside of the school.
Yeah. You have another question. Is there a lot of homework or is most of the work done in class?
Most of the work is done in class. Because there's things in class that you just don't have at home to do. I mean, you can do homework if you want. There's always that opportunity. The other thing I want to say is that I don't give any tests or exams, um, formal tests or exams. But what I will do is the projects that I mentioned earlier and the design problems, those are actually your tests and exams. So they're kind of fun because you're using your creativity. You're not having to sit there and memorize things in order to, spit them back at me, but you are using your skills and your creative process to serve as your exam grades.
Perfect. Anybody else? I should say, oh, does the program lead to any industry certifications?
No, it doesn't. I don't do any industry certifications. There are certifications that are available, like if you wanted to get certified an Autodesk inventor, that can certainly happen. But you can do that on your own by contacting Autodesk, and I would certainly help you do that and make that happen.
Cool. You're welcome. If there are any other questions, keep typing, but I want to let you know that if you're interested in the Engineering and Robotics course with Mr. Ornaka, there is only one. He's the only engineering and robotics teacher, and it's at Harkness. So that means there's only one junior class. So if this is something you're interested in taking and committing to for your junior and senior year, please, 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 and I sound like a broken record. If you've been with me all night long listening in, I'm going to say it again. Please contact your school guidance counselor or whoever is responsible for making your school schedule and let them know that you want to put this program into your schedule for the next 2 years so that you can get in the class. Class sizes are not huge, like there's not 40 seats. There's probably, what do you think, Mr. Onaka, maybe 20?
I can handle about 20 people, yes.
About 20 people.
Mm-hmm.
So please make sure that you let them know so that you are first in line. There is no interview process or what's the word I'm looking for?
Prerequisites?
Apply. There's no application.
Oh, yeah, okay.
It's like, it just flew out of my mouth. There's no application process for our CTE programs. That means it's first come, first serve. So make sure you're one of the first so that you don't have to worry about the waiting list. So yeah, we open our registration January 4th. So if you can do it before then, that's even better. And since it's at Harkness, I also want to say that if you are like a Hamburg student and you're concerned about getting there on time, your school will provide transportation for you to participate in the class. So if there's nothing else, that's our 30 minutes. Mr. Ornaka, thank you so much for being here again and telling us all about your program.
Okay, well, thanks for the opportunity. It's been fun.
Yeah, well, good. I tried.